Welcome to Programming Logic and Methods. This is our Made in Mexico version of Programming Logic and Methods. And let's take a look at what we're going to view today and what we're going to do next. First of all, I made a little miscalculation this quarter. I didn't realize we were a Monday class, I guess, and thus get Memorial Day off. So enjoy next week. That also means that this will be our last meeting. So we'll have, instead of a quiz, we'll have a comprehensive exam on exam week. So basically, if there's anything you didn't like about last week's exam, you get to do it all over again. The exam week exam will be the same format, 50 questions, timed for 60 minutes. And it will have a lot of the questions that were in the pool for last week, plus some new questions from today's examples. So, since this is our last meeting, it also means we're going to have one more homework due. And what I'm going to talk about today is going to follow this homework pretty closely. So let's take a look at the assignment. Design a class named Book that holds a stock number, author, title, price, and number of pages for a book. So the keywords here are book as a class, and then that holds a, that means that the words that follow should be attributes or variables defined in the class. Stock number, author, title, price, number of pages. The example I'm going to do today will be a class named income, and it will, well, maybe we'll call it something else. It'll be a class named, let's say, taxable income, and it will have some attributes like income amount, tax rate, so on and so forth. Okay, include methods to get and set the values for each data field. Okay, and we'll have a get and set for the taxable income amount and perhaps tax rate. Create the class diagram and write the pseudocode that defines this class. And once again, we will have a class diagram, and I will put together pseudocode in tonight's example. That should follow pretty closely with this homework. The class should have a method called display book details that displays the values of the book attributes. So I will have a method called calculate taxes or compute taxes that will do the same thing. Next, design a class named textbook that is a child class of book. This is brand new, child class of book. So that means we're going to learn a little bit about extending classes. In other words, having superclasses and subclasses. Include a new data field for the grade level of the book and get and set methods for the new field. Okay, so a second class, textbook, which extends book. Design a class named reader with the main method that instantiates an object of each class and demonstrates all methods. Thus, there will be two objects, that is, two objects created in reader total. There'll be an object for book and an object for textbook. This class should accept user input and then store that input into a book object and a textbook object by invoking the setter methods. It should then print the output using the getter methods. Include a class diagram showing the relationships among reader, textbook, and book. I said display the output using getter methods. As I look at this, actually up above it says call display book details. That will be fine instead of calling getter methods. Just invoke the display book details. I'll update this assignment to show that, to say it should print the output using get book details. So I'll update that. After this, we have the grading criteria. What I'm expecting for this assignment is pseudocode and a class diagram. No flowchart is needed. So if we take a look at these, it looks like I have about 10 defined. That'd be about 10 points each for each of those items below. So that's what our homework is going to look like. Now let's take a look at what we're going to be doing tonight, what we're going to cover. A lot of advanced material tonight, so I'm kind of glad I'm recording it so that you can stop, rewind, and replay it whenever you want. We're going to talk about constructor, getter, setter, and work methods, extending classes, inheritance, polymorphism. We'll look at a class diagram, and if we have time, the sequence diagram. We'll look at access modifiers, overloaded and overridden methods, and something we've already looked at, parameter lists, we'll cover again. So that's the goal for tonight. Okay, the big topic is going to be extending classes. Now, why do we want to extend classes? We extend classes because it allows us to handle some complicated situations in an efficient manner. In other words, the example I'm going to do today is going to be looking at income on income tax. And we know that there's this concept of income. Like if we earn income, that's a pretty simple concept. We earn income, we get taxed on it. But then we know that there are special types of income. There's dividend income, which has a special tax situation depending on how the income was earned. So a dividend is a payment of income from a company to its stockholders. That gets taxed in a different way, different category than normal earned income. So we see that the situation gets complicated. A dollar earned gets taxed a different way based on how that dollar was earned. And those are the things we're going to try to solve by extending classes. We also have the concept of a capital gain, a sale of an item at a gain or a loss. So a capital gain would be a capital good, something that lasts a long time, house, precious metals, stock, etc. Something that you sell, because it has value. You can either take a loss or a gain on it, and then there are different tax situations for that as well. So this is why we extend classes. This is why we extend classes to handle complicated situations in an efficient manner. It seems like a lot of work at first, but it really pays off when you're writing a program. In college, in a 10-week quarter, we tend to write 10-week programs. We tend to write programs that are pretty simple. As we get into really complicated programs, we find that we end up with a lot of logic. So if you think of software you like to use, maybe a game you like to play, or some software you have on your phone, think of all the different logic that's involved in that. Think of all the things the software does. Good class design will put that logic in an efficient place and make it easy to upgrade and maintain into the future. That's what good class design is doing. And that's why we want to explore this case of extending classes. Okay? So it gives us flexibility, an efficient way to handle special situations without duplicating code. We also want to consider another situation, which is a seller of software, somebody who makes software for sale, or somebody who makes a framework of software for sale. And again, I can point to my day job where I work in point of sale software. And if you think of buying something at a store, you think of looking at a point of sale terminal, or perhaps you even work at a store or work at a restaurant that uses point of sale software. No two are alike. So different customers want different things. Different retailers want different things. And what they'll say is many times when they are in the purchasing process, they'll put out a request for proposal, which will say, can your software do this? And that will help them narrow down the vendor that they want to choose to be their point of sale provider. Now, many times the point of sale software won't do everything, and so it will need to be extended by that customer. The customer might say, well, we have some specific requirements excuse me, for our business. How can we extend your software and add these modules and features to it? This is something we'll see every day. As software developers, we'll deal with this quite frequently. So once again, it becomes an important consideration to say, well, how can I organize my program so that it can be efficiently extended and used? There are a few different PowerPoints that I'm going to be going over today. I won't be reading them slide by slide, but for your reference, I'll show you what they are. Chapter 11, System Modeling with the UML is one. An object-oriented approach to programming logic and design. More object concepts is another one. Excuse me. And then object-oriented programming concepts, objects and classes is the next. Okay, so one of the things for the homework is to make some pseudocode that uses multiple classes. So what I'm going to do now is I am going to write a program. I'm going to write pseudocode for a program that I'm about to implement. Now, all quarter long, we've been working with this income tax program. I'm going to start fresh right now. I'm just going to look at a few things in isolation because since we have been working on it for a long time, it's gotten a bit complicated, and I want to be able to focus specifically on these concepts of extension and polymorphism. To be perfectly honest, they're confusing concepts, and so I want to take away anything that might add to that confusion. Okay, so first I'll say class, and we'll say income, let's say input income. That'll work. Now, on the pseudocode, when I'm grading assignments, I'm always looking for the begin class and the end class statements. So, a lot of times I'd see people begin a class or begin a method and not end it. It's always a good idea when you begin a class to end it right away. So, end it and then basically put all the logic between those two. So I'm going to say class input income and then end class. And then everything that's going to happen in this class will happen between these two lines. And of course I can add more lines in there, but by doing the begin and the end class up front, then I know I won't forget to put on the end class. Okay, so we'll say method main, return. Again, I start the method and I return it so that I don't forget. I put the matching begin in the end. Method prompt user, return. Method compute and display, and return. So at this point I have defined 3 different methods. Okay? In my method main, I'll say invoke prompt user. Okay, method prompt user, I'll say string more income to enter, more income to enter, that'll work. Input more income to enter. Okay, while more income to enter equals yes. Okay, so I'm setting up a loop, and I'm also setting up a few variables and some input from the user. Okay? Well, more income to enter equals yes. Say prompt. Well, we'll try and do 2 things in one line. We'll say, well, several things in one line. Double income amount equals prompt how much income from this source. Okay, and then we'll say string is dividend equals prompt is this dividend income. Okay, if is dividend. Geez. Okay, and we'll come back to that. Actually, I don't need a curly there. See, I'm going back to old habits and using curlies where I should just use while and end while. So I'll take out those curlies and I'll do while and end while. If is dividend, excuse me, we'll come back to that if it's a dividend, and if. Okay, we'll start with this. That will work for us for our prompt user method. So we're gathering some input from the user. Now, in your homework, you do not need to do a flowchart this time. So I'm not going to do a flowchart along with this. I'll just do the pseudocode. I'll take a quick check here of my pseudocode, make sure the indentation is correct, which it looks like it is. Yeah, that looks pretty good. So, okay, what do I need to do next then? Well, remember that the idea with object-oriented programming is to efficiently design our logic, put our logic in a sensible place. So the next thing I'm going to do is I'm going to declare a class called taxable income that's going to hold our income. Class taxable income. Okay? End class. Notice that this is flush left, so all of the end class and begin class are all in the same, let's say, column in this text editor. Okay? Now, within this class, I'm going to define an attribute And we'll call that double, or num. We can call it num if we want. Num income amount. Okay. And, oh, that should work. And then I'm going to define a method called num compute tax. We'll say method num compute tax in method. Okay. Well, gosh, to compute tax, I'm going to need a tax rate, aren't I? So I might say num income amount. I might also say num tax rate. Okay, so far so good. So if we take it, we'll see if I can get as much of this as I can. Oh, shoot, sorry. I'll get as much of this as I can on one screen. Okay, so at this point, we have two classes and we have a method. Okay, within the method, I'm going to say num tax equals income amount times tax rate, and then we'll say, actually we just need, instead of in method, we just need a return statement, don't we? So I'll just say return tax, and that will effectively close that method. There we go. Okay, so take a moment, look at that. And what do we need to do next? Well, gosh, we need to do our compute and display up in our input income, and we also need to consider what to do if we have dividend income and how to input this, because we're missing a few things up above. So what I'll say up in prompt user, now at this point this program's going to flow beyond the size of our screen capture here. So within prompt user, I'm going to say array all taxes. Okay. Within the while loop, I'm going to say taxable income TI equals new taxable income. This is effectively creating an object of the taxable income type. What do I mean by type? Remember, when we declare a variable, we need two things, a name and a type. Here I have a name called TI, and I have a type called taxable income. What is that type taxable income? It's this class we've defined down on line, looks like 31. Let me move this over a bit, and yeah, line 31. So when we create a class, what we can do then is we can make a variable where the type of variable is that class. And this is a very powerful concept. Taxable income, TI equals new taxable income. Okay, and so what I can say here is how much income from this source. I'll say TI dot, let's say, set income amount, and then parenthesis, and then we'll say income amount. Okay, now one thought though is that when we look at this ti.setIncomeAmount, we don't have a method down in our taxable income class called setIncomeAmount. That's kind of a given. If we have an attribute, we're probably going to have a getter and a setter method for it. And you see we have this method incomeAmount. Because that's an attribute, it's safe to assume we're going to have a setter method for it. So we'll save ourselves some typing and not actually write that method. This is only the case for getters and setters. Any other method we really need to make sure that we create. Okay, and now in compute and display, when I look at compute and display, I see it's going to need access to this array called all taxes. But that array is not visible to compute and display right now because it was defined within the method prompt user. Therefore, it's only available to the method prompt user. So I need to give this a little bit better scope. I'm going to take all taxes, okay, and I will make him an attribute of the class input income. There we go. And then basically that will make that visible to all methods. Okay, with compute and display, I'll say for. We can even say for each. That's a common loop. For each, all taxes, and then end for. Let's not forget that statement. And then we'll say all taxes dot compute. What do we call that method? Compute tax. And let's even say output. all taxes.compute tax. So we'll output each tax one line at a time. So there we go. So to recap, we have a class called input income. We have a method called prompt user and a method called compute and display. Probably we'll want to call compute and display after we call prompt user. So in the main method, after prompt user, invoke compute and display. Okay, and there we go. Now, we haven't handled this case of a dividend yet. And this is where things get tricky. Income's pretty simple. If you earn income, it gets taxed. That's all there is to it. Dividend income is trickier because the tax rate depends on if it is a qualified dividend or not. We don't have this concept of a qualified earned income. That only applies to dividends. Okay, so if it's a dividend, I need to do something above and beyond this taxable income here. I need to have a compute tax method that considers whether it's qualified or not. So what I need to do is I'm going to add a new class now, see at the bottom of the screen, and I'm going to say class dividend income extends taxable income in class. What does extend mean? Extend means that dividend income will have access to all of the non-private attributes and methods of the superclass. What's the superclass? What dividend income is extending. Okay, taxable income, superclass. Dividend income, subclass. A superclass is typically a generalization, something like a car. A subclass is a more specific type of that generalization. So a Prius is a car, a hybrid is a car, a Cavalier is a car. So when we extend a class, we're able to add attributes and methods that are more specific for a more specific case. In other words, I said that this concept of qualified income only applies to dividends, not earned income. So I can make an attribute here, let's say Boolean is a yes or a no, qualified. And that qualified will only apply to variables and objects of type dividend income. It will not apply to variables and objects that are just of type taxable income. Boolean qualified. Okay, now what I can do is I can make a special method here that looks exactly like the one in taxable income. Okay, method num compute tax. Okay, return tax. So far it looks pretty similar, but what I'm going to do here, because this is a dividend, is I'm going to say if qualified. Okay, then we'll say tax equals income amount times qualified rate. Okay, see, just out of habit I put a close semi-curly. Else tax equals income amount times tax rate. End if. So you see here that a dividend income is able to handle this concept of a special kind of tax, a qualified tax. We have the same method, we're just giving it different behavior. Same method, different behavior. Okay? So what I can do now is I can go back to my prompt user method and say if it is a dividend, we'll say taxable income, TI, equals new dividend income. Wow, that's really weird. Look at that. Our variable is a variable of type taxable income. You know what? Hang on. Dividend. That's too complicated. Let's just do it like this. Let's create a new object of type dividend income, and we'll call it DI. Okay? Now we'll say DI dot set income amount, and then we'll say, well, we need to ask if it's qualified, don't we? So we'll say Boolean qualified equals prompt, is this a qualified dividend? Okay, di.setQualified. Okay, there we go. Now, this is a bit redundant because you see we're doing a little bit of work up here on taxable income. So what I'm going to do, I'm going to rearrange this a little bit to make it a bit more efficient. We're going to need to know income from a source regardless of if it's dividend income or not. But this logic we only need to do if it's not dividend income. So let me Control X, and I'm going to say I'm going to put an else part on this if test. Boom, there we go. So you see what we have here is we're saying if it's dividend income, then prompt for some additional information. If not, assume that it's taxable income. Okay? If and else. One or the other of these is going to execute at all times. If it's dividend income, the first block will execute. If it's not dividend income, the second block that I have highlighted now will execute. These are mutually exclusive. Only one will execute, but one of them always will. Okay, only one of these will execute, but we know that either the if or the else will. I think we're good here. The last thing I might do is just say all taxes, which is our array, dot add di, and then down here in the else part, all taxes dot add ti. Okay, I'm going to save this, and I am going to, we're at the, whoops, okay, I'll save that in a moment. We're also at about the 27-minute mark, and these take a while to upload. So I'm going to pause this recording now, and then when I start the next session, we will start by actually implementing this in code. And even before that, we'll take a look at how we can implement this with UML. After that, we'll see what kind of behavior we get when we try and run this. So I'm going to stop the recording now and start a part 2 in just a moment.